Okay, next up, solder in the microcontroller socket and make all connections required for final installation with all subcomponents of the microcontroller put in for the buck converter. Got it. I can do this. I'm ready for this. Let's do this. Woohoo! Man, this has been a long time coming, boys. I mean a long time. 8 months or something insane like that. Like a ridiculously long time. We are about to create our actual circuit, not just another... I mean, I created multiple circuits. One was a programming circuit. One was a firmware bootloading circuit. Well, we're finally making the actual circuit here. The actual circuit. There's a big difference. Okay, this is the wrong chip, though. Where's my other chip? I need my original chip that I've already bootloaded. Must be in here. No? That's interesting. It's not in there. These were the 2 circuits I made in the past. Big messes of wire. That's how all my circuits will look. Like a mess of wire. It's called deadbug style circuit making. It's a very cool way to do it, I think. Alright, well, I'm not seeing my my bootloaded Arduino, so I'm just going to use this non-bootloaded one. It's fine though, because we can just bootload it later. Right now we're just interested in creating our circuit. Testing the circuit will come much later. Getting the microcontroller to pop into the socket can be a little tough. No, mailbox is not talking. Is he in the viewer list? Hi, Mike. You need a needle nose pliers just to get this microcontroller popped into the socket. Alright, it's in there now, finally. Man. Uh... Huh. I want to try maybe using one of these. I know I'm against it in general, but I'm just curious, man. Huh. You guys think I should use this or not? It's not dead bugging if you use this. That's a concern of mine. I kind of wanted to be a dead bug guy. But it seems like this using a board like this would make things a heck of a lot easier in several ways. It's called a perf board or a prototyping board, I believe. So this challenge is how to cut this perf board. Between 10 and 11 we're gonna do it. Okay. Let's score it maybe a few times, nice and deep. Alright. They said to snap it. I'm kind of scared about this. I kind of want to snap it with support for where I'm snapping. Not bad. That's acceptable. I guess I could snip away with this, the rest. Electronic side cutters. That's pretty good. Then how about a nail file? Just smooth it out. So there you have it. Score it with X-Acto knife, electronic side cutters, after snapping it in a supported manner with something thin, like a knife sticking up under it as you break it over that point, just to guide the pressure. And then sand it with nail file. Not bad. So there, we just cut our perf board, or our Vero board. That's a pretty clean job, I think. The idea behind that is just, I don't want to have a ton of extra board that I don't need taking up space in projects. I just want to use as much board as I need, like really need. Otherwise things will get messy. But yeah, I think I am going to use the Vero board here. It doesn't take up a whole lot of room, I guess. It looks like it'll help me position parts and stuff. Oh crap. Put on too much. What the hell? Ha! I just burned a little copper trace clear off the Vero board. That is not cool. Holy crap, that's so bad. Oh my gosh. Copper pads just popped off just like that. That's not usable then. It's like the copper pads on the Vero board are being held together by frickin' scotch tape. This is ridiculous. That's so poorly made, it's really not usable. That's terrible. Alright, I'm going back to my old ways. I was trying something new. I really wasn't happy with the results. I'm just gonna, for now, just revert back to something I know that works fine and I like. Can always try VeroBoard again someday, but I'm not happy with how that worked out for me. Kinda sad, but it is what it is. You know, I have another idea. I kinda still want to use the VeroBoard, but I could use it in a different way. There's still hope. I gotta look at this as like art. An art project. There's no easy answer. This is a straight up art, man. This isn't a bomb being made, this is a robot being made. I'm working on super cool stuff right now. Right now I'm gluing the socket of a microcontroller down. You can see I flared out the bottom legs of the socket, and I'm using the back of the perf board. You can see they're flared out on both sides, and I just glued the socket down right here, and that edge, you can see the glue is shiny still. I just used little drops of super glue along with little drops of super glue accelerator from Bob Smith Industries. I found that it's better, rather than to spray it on, you just unscrew it and you use the little straw to dab it on. You could just put a single drop on. It's a lot more efficient, less waste of material. I think that's a better way to do it. I was having a lot of problems with this perf board or Vero board. These little copper pads keep coming off. They're just not on there. There's multiple ones missing. So I'm just going to try a totally new approach and not really rely on those pads so much. Or at all, maybe. Haven't decided how much I'll rely on them, but definitely was time for a change. Why don't you put the pins through the holes? I still haven't come up with a good explanation for that, except for I want to be able to see all the connections from the top, see that they're good, analyze them, solder to the pins from the top, treating the pins as the traces themselves, since I don't have traces. I wanted to create traces of solder bridging the various copper plated holes, and those soldered traces, just lines of solder connecting those holes, would be like my circuit board traces. That was my original plan. That's how most people use Vero board. But this super cheap Chinese Vero board, the little copper plated pads on this side just pop off constantly. So I don't trust them at all. So I'm just going to use wire directly to parts, wire to wire. So I'm going to do a dead bug style soldering of actual component, through hole component wires to the pins. I'll be able to see the solder joint, access it from the top only, and I'm going to treat this board as just a backer plate, just to organize things. I might be able to put, actually I don't even know if I'm going to use through hole components and put the holes through the holes. I think I'm just going to use this board as just a backer, really. I don't trust this board at all anymore. It broke my trust. I even threw this board in the garbage and then I just pulled it back out because I had an idea just to use it still for layout and just to have the grid shape and just to help me in that regard. But as far as using it for its proper normal use case, it's just the board is so cheaply made, it can't be used in that way, in my opinion. Because, I mean, I just barely touched my tools to it, and instantly the copper plates were just falling off the board. It's just so poorly made. Can't handle anything. I'm gonna glue the other side of my socket down. For some reason, my glue bottle dried up super fast. Alright, we should be okay now. Like I said, I don't want to mess with the other side of this board ever, because this board is going to be outward facing and I need to be able to inspect every joint and every trace for troubleshooting, for testing, etc. And the back side of this board will not be accessible. I don't want to have to remove the board every time I want to mess with anything on the board. So this board is just being used as a place to glue parts on. Might as well use just a piece of wood. Just gonna glue parts onto it. Use the little grid to see numbers and letters of rows and columns. That's the extent of how I'm gonna use it. I might make some exceptions to that as I move along, but my gut tells me that that should be where I draw the line, considering the terrible performance so far of the copper pads, which are supposed to be, you know, the whole point of this type of board, and they just fall off with the very slightest of touch from anything. They just instantly fall off, so I don't trust them anymore. Okay. That's on there nice and solid. pleased with that. Um, where do I start? I know where I want to start. Well, maybe not. We're getting ahead of ourselves. Alright, let me determine which one. Okay. Pin 7 is VCC. So 1, 2, 3, 4, 5, 6, 7. That's I on the board. Okay. What am I doing? I'm just positioning capacitor as close as I can to the pins I want to solder it to. Dang it. Gosh. Okay, that was bad. I did bad. Let me start over. I got way too much solder on this thing. Oh. Oh, please. Alright. Just gotta be patient. Nice. Okay. That joint looks good. Alright, I want to like thoroughly clean this soldering iron. I think that I kind of messed it up by having it on for a long time recently. It's all like messed up. Okay. Um, I just have too much solder on it again. I gotta put just a tiny amount. That's more like it. Beautiful. Look at that. Okay. So we got the capacitor on real close to the VCC and ground, which is the I and H, or pin 7 and 8. That's nice. And then from there we need a 10k ohm resistor to the reset. Holy crap. We need our switch. Okay guys, that's what we got so far. Kind of making my thing 3D here. What next? Got him. Okay. Alright guys, this is what we got now. So we got this here is our 7805 regulator. We connected this capacitor to the center pin of it, which is ground, and it's an electrolytic, and this gray band right here, you can see it, marks where the ground should be. The other side is just plain black, so that goes to the non-ground, the positive. So I soldered that one to the positive here, like there, and the right pin I centered to the middle, and then this little 104 ceramic capacitor, which is a 100 NF or 0.1 UF ceramic capacitor, I soldered its left leg to the center, which is the ground, and its right leg to the right pin, which is the out, 5 volt out of the 7805 5 volt regulator. And then the 5 volt out, I just went straight across and into the 7th pin of the microcontroller socket. And the 7th and 8th pin are VCC and ground. 8th pin is ground, 7th pin VCC. And I put this capacitor as close as I could to it. It is a 0.1 UF 100 NF ceramic capacitor as well. You're always supposed to put one of those really close to the VCC and ground pins. And then here, we've got coming off the voltage rail, swinging off to the right, we got a line that then solders onto this LED, which will be a status indicator LED. And then that comes across to a 10k ohm resistor here, which then goes to the first pin, the reset pin of the microcontroller socket. And then from that pin it goes over to this reset switch, which you can press to reset. I still haven't soldered in the ground side of the reset switch or the ground side of the LED. I'm going to do that next. And I'm going to bring that right off the ground of the 7805 regulator. I'm going to bring a thing down, over, and then around, which I believe is next. So yeah, this crazy amount of parts is starting to go in here. Starting to get them. It's just a ridiculous amount of parts though. That's why I had to think about it so much, to make sure I could figure out where they're all going to go, get good access to solder each one. It's very... Nice. Yes. Okay, I'll just clip. We're fine. I just gotta clip this wire off. Pop this out. Um, Let us see. Let us see. Ooh. Time for wire. We need wire now. Black wire for ground. Huh. That's odd. Okay. Dang it. Okay. Now I need another piece of wire. A red one. Huh. Hmm. Yeah, I gotta stop. As fun as this is, this has been, I can't just YOLO go way over on time. Wow. I mean, this has been quite fun. It's really happening, man. Can't believe we got all those parts in. 1, 2, 3, 4, 5, 6. Holy crap. 1, 2, 3, 4, 5, 6, 7, 8. 8 components. 1, 2, 3, 4, 5, 6, 7, 8. A very tiny area. It's interesting. I didn't need helping hands at all today because I'm working with this board. Things kind of get to be pressed into place somehow. I don't know. It's a lot easier, it seems. Well, the hard part was just figuring out where I want to put everything. That was tricky. So you can see off the bottom I pulled the ground and power lines coming off the regulator. Actually, okay, so the ceramic capacitor here, the pins came and soldered onto the legs of the regulator, and I have them both stick out the back, and then I was able to solder jumper wire onto those, and then carefully string the jumper wire along the top ridge, and I hot glued it here and here, right there. And then I also was able to finally connect the ground for the LCD through the 220 ohm resistor, and then that connected to the back of the switch. So now the resistor will have ground through the the LED will have ground through the resistor, and then I just continued with that same leg of the resistor all the way past the LED, up and through, and then tied it into the ground line here, which came off the ground from here, which we just described. So we have a ground coming all the way through, and we were finally able to tie in. And now we've got these two lines, ground and 5 volts, regulated 5 volts, that are going to supply our analog stuff. And if you look here, let's see. So you can see kind of like we came off the back of the regulator. We had the regulator drawn like this, but these two lines we always did plan to come up and over the top. Black and red. There's going to be an inductor involved, 10 microhenry inductor coil, and 100 NF ceramic capacitor, and those all just provide smoothing so that you have a very smooth analog reference, analog pin, VCC, and ground for the analog. So, and then you need 100 NF ceramic capacitor between analog reference and ground, and then this ceramic capacitor is obviously between VCC and ground. So you're going to want these two capacitors as close to the pins as possible. So that's what I have to do next in order to complete the wiring. Also, I have not yet put in the crystals. So the two pistol pins come out to the quartz crystal oscillator, 16 megahertz, and then that goes through two ceramic capacitors, which are 18 to 22 picofarads. I chose 22 picofarads, but 18 would work. And then those both merge into ground. Then I'm going to put in, on digital pin 8, I'm going to put a LED and then a 220 ohm resistor. And this will be my blink LED. So I'll run a blink program, and I'll be able to see that everything's working okay. I'm also going to use this LED as a tool to give me like Morse code. If there's any type of errors, or if it just wants to tell me things, I'm going to have it do like a series of flashes to mean various different things. So I'll come up with a code system. May not be Morse code, but like a code count. So there will be like a silence for 2 seconds, and then it will say something, and then a silence for 2 seconds, and it can say many different things. And to say things, it's going to flash bop, 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 and depending on the flash count, it might flash 5 times or 8 times or 10 times, whatever it is, will correspond to a different message code. And then I can just create message codes and look it up from a chart, and I'll see the various things it's telling me. And it can tell me all kinds of things, including like errors or things are all good. It can give me measurements as to like various readings on its analog input pins, all kinds of stuff. So that could be a communication method for it to visually communicate different things that it's thinking. I did consider putting on a little tiny LCD screen, which I have, and it's compatible with this, but it takes up like 5 or 6 pins, so it just seems kind of impractical. So I think, if you need it to be able to tell you readings and stuff, just a flashing system should be superior in my opinion, so I'm going to go with that. And that will all be thanks to this digital pin 8 LED. It's going to be the one that talks to me. So yeah, we're making great progress. I am happy with the use of the Vero board. This is not the way a Vero board is really intended to be used. On the back side, I did try doing some soldering to the Vero board, and every time I held the soldering iron on there for more than like a split second, the copper plate would come off and stick to my soldering iron, which is pointless then. If they're going to come off that easily, I really can't use the copper plates. I can't rely on them then. And I mean easily. So what I ended up doing is just super gluing the microcontroller socket directly onto here. I bent out all the legs. I just splayed them outward, which is kind of hard to see. There you go. You can see they're all splayed outward, and I'll be able to just solder directly onto them. They'll be like my soldering pad. And I'm just pretty much soldering components on. I made sure to keep a good amount of clearance underneath the microcontroller. As you can see every pin. I kept that clearance so that I can get a soldering iron at this angle to solder on to each pin different wires I want to solder on, to control the various MOSFETs or whatever, analog input pins, whatever I would want to control. So I created that clearance. Pretty much this whole left section I dedicated to creating a regulated 5-volt power source, and then this top section is just LED with its resistor, and then the pull-up resistor for the reset button, and the reset button, or the reset pin I mean, and then the reset button for the reset pin. I wanted a reset button even though it's not necessary, because I feel like I could have it do certain things on a fresh start, like tell me certain readouts and stuff with the flashing light method. And then later on maybe it will stop with the flashing lights, or it will flash lights like more periodically, but right away it might give me a series of messages that I can access very quickly just by restarting it. So I think that could be a cool tool, just to have that button for various things later on when I'm getting into debugging and advanced stuff, and I'm doing a lot of coding on it. So I think that's a nice way to interact with it. So that's what all this stuff is. And then these two capacitors and regulator all go together. It required those capacitors to go with it in order for it to work consistently. And then this little area here, I'm going to have the quartz crystal oscillator somewhere around this area. I don't know. I don't want to get too close to these pins, because I need to leave enough room for getting access with the iron to apply additional wires. There's got to be room. So I don't want to clutter anything too close to the actual microcontroller. Everything's got to be along this perimeter with at least like a 1 centimeter gap. That's what I've been focused on ensuring. And another cool thing, well, I was going to say I could come up from the back. I could put a wire through and then bend it over and solder it into the pin and then come out the back with wires to go to various places, but I don't like that because I want to be able to visually see a wire come in from wherever it's coming in from the project and actually attach to a pin. And that's why I didn't put anything on the back. I want to be able to see everything and test everything with a multimeter. I want it all exposed and I want it all on the front. I think that's a lot easier to be able to visualize everything that's going on and see any mistakes just looking at the front. You don't have to do any fancy tracing. You can just literally see it all with your eyes just right there. Maybe tilt it a little bit to see, since there's some connections behind the 5-volt regulator, you have to tilt it to see those. But for the most part, when you look at it in the front, you can see everything that's happening. It's all right there. And I think that's great. So you can see if something came undone or test different points. I think that's just the best way to do it. So I really like the way I did it. So yeah, I guess you don't need really to use the Vero board as anything more than just like kind of a place to glue on your, a handful of components and wires, and to have a way to mark things, because it's got a grid where it counts along the sides. There's numbers you can see, and then along the top there's lettering system, so you can keep track of column and row, and I felt that was really convenient. And yeah, I think it gives kind of some structure to things, like they're not just kind of flimsy and all over the place. Like when I did completely dead bug with no board, things were just kind of all over the place, and I think that's good for certain situations, but I think that this is really nice to have a board if you can afford it. Like, I would say putting things, like, this is still kind of dead bug style though, but it's dead bug style with a board kind of supporting things and helping organize everything. So I do like having the board. So I'll default to the board unless if space constraints dictate otherwise, and then I can go full dead bug if I need to. So I'll have the flexibility to choose, but I'll prefer to use the board though. So yeah, man, we did it. We crushed it. This was an excellent session. I'm really happy to see that this crappy perf board / Vero board, even though it failed me as far as like creating traces across the little copper pads goes, that was a complete failure. Turns out I don't even need to do that. I don't need to do it to use it in that way. So everything ended up going well, despite that little setback, disappointment. So I will be able to keep the mountain of little Vero boards I bought and still be able to use them. Thank you, Dimebag. Because I actually thought I was going to have to throw it all away originally. It just seemed like such a bad quality product. But now that I'm not going to use it the way it's really meant to be used, now that I'm going to be using it for something very unorthodox, it actually serves my purposes very well. Yeah, this was an excellent session, and in 2 work days, I'll be back to electronics again. Because today was Robot Bone Day, and since I'm done with all the really important bones already, I don't have to do bones on Bone Day. I can do electronics on Bone Day for the time being. So I chose to use Robot Bone Day this time as Electronics Day. So I still have Electronics Day to look forward to. It's part of the main project rotation. So I'm kind of doubling up, getting to work on electronics twice per rotation. Once on Bone Day, once on Electronics Day. And that's nice, because the electronics have been a long time coming, and I can't have them done soon enough, man. I'm very excited to see my electronics come to reality. come to fruition and be usable. And we're getting real close now. Just like a handful more components, and we'll be able to plug it in and start seeing the flashing LED, and we'll be able to start coding the microcontroller and connecting up all these MOSFETs, which are already set into place. We'll be able to make our own custom inductor coil for our buck converter, put in our final couple of capacitors, set up all of our voltage dividers for voltage reading for regulated output of the buck converter, and finish setting up our crowbar circuit, and then running tests. And those tests should tell us what kind of timings we need on the on-off of the buck converter in order to get the proper voltage going. And then once we get the right voltage, we'll be able to connect it up to the vacuum. But the vacuum will still need a lot of additional work done to it as well, though. So yeah, I mean, this is an exciting time for the project, I think. Things are really starting to come together here.